We are recording. Welcome to the evening of Python coding. It's a meetup where we have people join us to see a demo of a Python tool or library. We've been doing it for many years now. Today, I'm very pleased to announce Surav Saha, and I hope I didn't butcher the name. So please, if I did it mistakenly, please correct me. He was going to talk about fire ducks.
Yes.
Uh, it's a very, very interesting alternative to pandas. We had several of those presented in the past, but this is really new, and I'm really, really excited to hear about it. So, Surav, the floor is yours. We're ready to hear about the fire ducks.
Okay. Thank you so much, Jacob, once again, and thank you the team, and a very good evening. This is like I'm really excited to present our work before you. So I believe that most because when I checked over the internet and I found that this community is something where we are discussing on different Python kind of tools like data science tools, be it pandas, be it Martin, be it Vex. So since it's a really that platform where you're already aware of such kind of thing, and many people might be using it in a daily, like a daily day-to-day work. So it is like immense pleasure that I can introduce this library before you. And as we discussed, like if you have any question in between, please feel free to interrupt me. I'll be happy to like answer whatever question you may have. So, okay, without taking much more time, let me introduce quickly that what is our motivation and who am I basically. Basically, my name is Saurav. So, I'm from India, but I'm here in Japan and working at NEC over last 11 years almost. So in this journey, I have initially started my career with high performance computing. So and basically NEC is known for its own supercomputer. This supercomputer basically for vector supercomputing, usually known as SIMD computing. So started my career with those vector supercomputing where we used to get some legacy applications from different university and used to optimize them on our supercomputer and for get greater performance. And there gradually moved to some distributed computing and big data and machine learning came later. So I gradually started, and currently my team is mainly working on different data processing related algorithms. So what happens is that all in this entire journey, like from A6 supercomputing. So this is basically a snapshot. Like A6 started, and currently the latest version is A6 Aurora Subasa. So all this thing. So when I joined, so basically my leader named Mr. Ishizaka. So he's the primary author of the tool, which I'll be explaining in a couple of minutes. So the Ishiaka-san, so we say san after the name. It's a Japanese practice to give some respect. So usually Ishiaka-san, my team has thought of like, since we have this kind of expertise like distributed programming and compiler technology along with the data processing. So let us create something. So it's better to create some library using the compiler technology because Python is slow and we can optimize Python. So all these because become the motivation for us. And since it was a very new like known thing that using pandas, I believe many of you are using pandas.
Sorry for interrupting you. Can you dismiss the share screen thing that appears on? Yeah,
Okay, okay,
yeah. Thank
sorry.
you. Apologies.
Hmm. So yeah, so as you might be knowing that pandas is one of the very important tool. At the same time, it is very slow. So it's really like when we use very large data, often we stuck with problems with the performance related issues. So we thought of developing something using the technology which we have, and at the same time solving the problem which the community currently facing. So that is when the fire ducts have development is started. So down the line, what it is all about. So I'll be explaining all its architecture and some technical thing in a later slides. But basically, if you know pandas, you don't need to know anything new. So you will have something in a pandas, pure pandas program you will be writing, and down the line, it will be executing the API which you have written maybe for group by, maybe for joining related stuff. But it will have its own compiler, and the compiler will do a lot of magic. So what kind of magic it will do and what kind of thing you can expect, I'll be coming to the later slide. But that was the core motivation of starting this project. So now, again, I'll not take much time on this slide. It is just about to show that pandas is one of the very popular among the data science community because of its very like age-old history of being there, and there are many like textbooks available. Nowadays, also the download is like over 100 million. So, like having such a tool and which is very popular among the data scientist, analyst, whoever is working, so it's good to have something better which we can help to, like, it's add-on service on pandas which will you let you use the pandas as you're using, but at the same time the problem which you're facing with pandas that can be addressed. So now what can be the problem? So again, it might be known factor to you, but just to add on in simple notes, pandas is something which is written, first of all, it is a Python specific library. So often most of its code is written in Python, so you may not expect that C level speed when using Python. But apart from that, you have another problem, that is it doesn't support parallel computation. So even if you have a multi CPU code system, so you won't get the performance benefit out of them because the main computation is only being executed on a single CPU. So that is a major pitfall with pandas. Apart from that, it doesn't manage memory very well. So if you're actually, even for numeric data it's still fine, but if you're going for some object kind of data, for example string data, some other non-numeric data, so it does really bad with the memory and you stuck with the memory related issue. So that is again a problem with pandas. But the current situation, like there are different execution model. Pandas is kind of a very traditional library, so it does offer you some eager execution model. What does that mean is that when you request pandas to do something, for example, you have a file and you want pandas, please load the file for me. And for example, okay, after the loading, please perform a sorting for me. So it will do once it receive the request from your side. So it doesn't wait for your final, the entire instruction to be read and do kind of optimization based on that, because it's kind of eager execution model. So it does whatever is requested right after they are requested. So that is something which doesn't allow you to do kind of native optimization. And also the code is very traditional, so it doesn't offer you like quite optimization based on different modern processor which you may have, for example CPU or the modern CPUs and GPU related thing. So that is a problem definitely. But the major problem which I want to highlight here and which we are about to target, that is its writing style of a pandas, because it has been developed over time and there are many community who have been engaged in the development. So you may have a couple of different ways of writing the same thing in Python, in pandas. So for example, if you want to do extract something from our data, so you have a couple of ways. So it's often a problem, like since you have many choices, so it's difficult to pick the suitable one for you, for your particular need. And if you don't choose the right API, even the API is right, the API comes with different parameters, the parameters might not be right. For that case, pandas will not be that fast. So this presentation is all about like how we can write better pandas. And if you can get to know that, so next it will be like how all those things which I'll be covering can be automated using our library, which has a compiler which will do the magic. So okay, so let's before jumping to fighters, just give me a few seconds to cover that why do you need so. Although I have said already, because being a data scientist, our day-to-day life, we do a lot of different exploration on the data to solve some business problem. But what happens is that we start with something and the execution is, the simulation is in progress and we spend a lot of time, and then before starting the next simulation is already very late, so it's often impacts our efficiency, right? So of course, if we can do a faster simulation, we can do a lot of different analytics in the same day, so that will definitely increase our speed of research, increase the speed of our analysis, and overall it will be very beneficial for the business. The secondly, the cloud, of course, because nowadays most of these analytical tasks have been switched to some cloud related platforms, and cloud comes with its as you can really relate to that, like the more the execution time, the more the cloud cost you may need to pay. So of course, if you can reduce the execution time by 10 times, so your budget or your entire cloud rental cost will also be reduced. So that will be a great benefit, I believe. The third, and not the last, but most important, what I believe is like if you have many data servers and the long run execution is running on those servers, so definitely a lot of carbon dioxide is going to be emitted. So if we can trigger that point, so it will be really like quite a eco-friendly solution if we can create. So of course it will do uh, that job which you want, but with a very less server and in a very limited time. So definitely we can help contribute a lot, like green thing for our environment. So all this taken together, so this is really a good motivation to start some project which can help the society and the community with all these aspects. So now it's the execution model which Pandas has. So again, it's very known to you. So you being a data scientist, being a data manipulation specialized or data analyst, you will write kind of Pandas program. So when you write a pandas program, what happens? It comes with a lot of API, which is specifically specialized for data frame related tasks. For example, read CSV for reading the data, then join for merging different table, then sorting and etc. So that is there in your Python front end. All these library functions are piled up here when the program is written. And that exact program will be executed as it is by a single CPU, which your environment may have, and it will be executed. So even if you have multi-core available, so the one after one API will be executed in one of the CPUs, and the rest of them will not be unused. So that is the thing. Like the user program will not be optimized; it will be executed as it is, and one CPU will be used. So we would like to change something in this execution model such that these two problem can be corrected. So that is where Firetux comes with the almost the as a user. As a user of Firetux, you don't feel that you are learning something new because the on the top of it, it is pandas, and you will feel like you are writing a pandas program. But like because the API is same, the API is same, the input argument, the type of the input, the type of the output, the parameters, order, everything is same. So when you have a existing pandas code, you don't need to learn anything new. But on the bottom, everything is different actually. So top it looks same, but bottom it's different. How it different? Because the front end, which has a library function definition, that has a compiler also, and that compiler is just-in-time compiler. So it does inspect whatever instruction you are about to execute. Based on that, this compiler is specialized to do kind of optimization. What all about the optimization is possible? So I'll be coming in up. I'll be explaining in upcoming slides. But here not only the library function, there is a compiler, and this compiler will be smart enough to inspect the current issue in your code, and it will do kind of optimized code like the C++ compiler does, and then the optimized version will be executed by the C++ kernel. Again, the kernel is completely written from scratch, so all the algorithms like join, relate, join, filter, merge, whatever the algorithms are, those have been written in scratch in C++, and those are multi-threaded. So if you have a multi-core system available, even if it's a very low spec system like 2 CPU, 4 CPU, the hardware is not that good. But if you have multi-core available, so it will be taking the leverage out of that. So of course, your program will be much faster when comparing to pandas. So the benchmarks and all about all how fast it is, all those things I'll be covering in upcoming slides. So that is the model. So now, because this has two very powerful layers, so let me explain that what features you might expect from each of these two layers. The first thing, since it comes with a compiler, so you can expect whatever compiler specific optimization you may have been knowing. Here I am, although uses the technology, the technical terms like common sub-expression elimination, popularly known as CSE, the date code elimination, something called constant folding, etc. So these things are basically done by a smart C++ Reddit compiler, but again, with Firetux, it's possible for your pandas code as well. So what it is actually, so I'll be taking an example and explaining it in upcoming slide. The second thing is domain specific optimization. So if some of you have already been using SQL kind of data processing language, so you might be knowing that SQL does a lot of query related optimization once it receives the exact query from your side. So those query related optimization uses some kind of domain specific knowledge. So all those domain specific optimization are possible when you use Firetux. For example, in reordering of some instruction based on the speed or something. So again, I'll be taking an example and explain that. The third is because it is about improving the pandas. So you may have, as I said, you may have a lot of different pandas API. The API comes with different parameters. So whether the parameter is right or the API is right, that kind of optimization can also be taken care by the compiler which we have. So taking all these three together, so you can have a complete different optimized code when that will actually be executed at the backend side. And the next thing from the backend, what kind of optimization you can expect, which is not possible in pandas. First thing, it comes with the multi-threaded computations. Of course, if you have a multi-core CPU or CPU available, so you can take a full leverage out of that. The memory, it is backed by Apache Arrow mostly. So you can expect a lot of gain in terms of memory. For example, complex data like string data, Boolean data, etc. So it will be much less in comparison to pandas. And of course, as I said, all the kernel threaded algorithm for group by join, those have been written by our own patented algorithms in pure C++. So you can get the C speed along with the advantage of the algorithms. So, and that itself will give another performance add-on to your thing. So all this optimization possible just using one kind of change in a source code, or sometime there is no change even needed. So again, I'll be coming in upcoming slide. So let me take some very simple example which you can relate and which you can understand. Okay, this kind of optimization I'm talking about. So first, it is some compiler specific optimization.
Sarah,
Uh,
Sarah, you're talking about optimization on one machine?
yeah, I'm talking about
We're
optimization.
not talking, so you don't extend it to a cluster yet.
Yes. So it's
Okay.
not about like distributed computing. It's about single node computation, the single node having multi cores available.
Okay. And can it handle currently GPUs and stuff like this, or is it something that you're thinking in the future?
Yeah, actually, GPU development is not yet publicly available. So currently the CPU version is there, so and it is being evaluated. But the future one, it's being worked currently. So the GPU version will also be available very soon.
Perfect. Thank you. Apologies.
Mhm.
Go on.
Okay. So here it's about the compiler specific optimization. So before thinking what kind of optimize it might be, let me take an example. This is very basic example of calculation of Indian salary, Indian employee salary of different from different industry. So from the, whoever is already known about pandas, they can really relate to this query. For example, still let me explain it to a native perspective. Like since there is a wise related call industry wise, so I need to perform some group by on industry table. And then since my target employee is from India, so I need to perform some filter on the country, and the country should be from India. And finally, I need to perform the average on the salary column. So the salary column is to be selected and mean is to be computed. That is basically the query is all about. And it's purely written in Python, pandas. So that's when we start writing this kind of query. So often we don't end up with one query. We do a lot of different queries to get the real insight out of data. So after doing this analysis, maybe as a data analyst, we perform some different analysis on the same thing with the, maybe from different condition. For example, here everything is same. So I just have added one more condition, that is, okay, the Indian employee, but who is above 30 or something. So I just added one condition here and the rest of the query looks fine. So employee age should be greater than equals to 30. So, and I'll again execute the code and I will inspect, okay, what is going on. So if you check what happens here, like for example, just for two queries, what happens here, I probably due to the copy or whatever it is, so I have probably used this kind of filtration, like from the employee table, filter all those employee who are from India. This kind of filtration is something which is repeated in these two queries. So since it is repeated, so it will be executed twice. Now the thing is like, imagine like if you have a very large database for employee and where there are many employees from different countries, so it may have a lot of cost in this filter if we do the same thing more than once. At the same time, country being a string column, always like the comparison on string is something costlier than comparison on numeric column. So string column comparison itself is costlier, and if you have a large employee database, having this thing twice might impact your source code when it will be ready for the production, and or you may have a lot of data. So our native compiler, usually which we offer in a C++ kind of thing, they can detect that this kind of expression is called the common sub expression in your source code. So what it does, it detects, okay, so I'm using this condition twice. So okay, before doing the compiler, so if from a expert in this domain, so what you can think of upon detecting that I'm using it twice, you can just simply to make it one time, what you can do is you can just create this condition once. For example, okay, so I need to do this kind of condition check, so let me execute or evaluate the condition once, and let me reuse the evaluated expression in my couple of queries. So with these changes, you can expect that condition one to be evaluated once and the result will be used wherever it requires. So this thing, something is called common sub expression elimination. So you have a couple of common sub expression, and that will be eliminated from your source code because it will be executed once and reused whenever it is used. So this kind of optimization are typically done by a compiler, and since Firedux has its own compiler, it can do this for you. So even if you write this code in your Jupyter or in your Python script, so down the line it will find there are common expression and those will be eliminated with the code something similar to this. So that is one typical example which can relate from the compiler background. Now comes to the second example, that is some like while ago, like there are domain specific optimization which is again possible. So when I say domain specific optimization, probably we always don't think on this, but if we think this carefully, we can save a lot of execution time when using even native pandas. So what it's all about, for example, you have this data. This data comes with 10 columns. There might be many rows, but for the sake of explanation, there are only 6 rows right now, but there are 10 columns. And what I want to do is I want to perform the sorting on my B column from this data. And from the sorted, I just want to extract the A column. So basically, I want A column to be extracted, but that result should be sorted by B column. That is what I want. And this is the data, for example, which I have. So if we execute this, there might be something. So is it possible? Like, can anybody can volunteer? Like, okay, whether this code is fine or what kind of optimization is possible or anything? Is there anything which comes to your mind? If doesn't, then of course I will be continuing and explaining it. So can I have a quick call from anybody who may volunteer? Like, okay, these may be like there might be this problem and we can may like to address this by doing this way.
You can eliminate C to J, like
Okay.
you don't need them.
Perfect. Thank you, Jacob. Yeah, actually, this is the thing. So, what happens down the line? So, let me now explain it pictorially. So, when we do sorting, basically sorting again, sort the algorithm of sorting can be different, but the generic way is that when we do sorting, so first of all, it needs to perform some kind of index reorder. So, when it will be sorted, what will be the actual index of my result? So, for example, if I do sorting by B, what happens is that there will be a column, so I need the zeroth row followed by third row, then I need to take the B, so 1 followed by 5 and then 4 followed by 2. So this is something should be my sorted index, and once the index is computed, usually the result is materialized. So the materialize means I need to extract those row in that order from this data frame or from this database or table, whatever you have. So that is the core algorithm which execute behind the scene. So now if you see what happens, like if I take, which is basically an API from data frame, if I take those row from the sorted order, this will be the situation. So I'll be taking zeroth row followed by third row followed by 1, 5 and 4 and 2. So that is there. And since I just need, I'm interested only the result to be from the A column, so I now can extract the A column and my result will be whatever I need. But the major problem is, as Jacob rightly said, that is, since I'm only interested in A column and the result is again to be shortened B column, so I don't need the column from C to G to be incorporated in this example. But since I have already did so by saying the short on the entire data frame DF, so there is a lot of computation memory and execution time which is going to be a waste, because those will be used, but that will be of no use if from your requirement perspective. So, as a manual optimization, what you may think of, you may need to think of, okay, so I have, even if this is my entire data, by my interest, area of interest is only this part, A and B. So, let me slice that pause first. So, I'll be slicing the A and B column and create a temporary data frame. And then I'll perform whatever I'm executed last time. Like I will be shorting, and the short will does the exact same thing. It will perform the shorted index, but this time the extraction of row will not be on the entire data frame. It will be on the temporary slice which you have created. And then you will be extracted the exact column which you need. So this kind of source code can be very well optimized by manual optimizing, something similar to this. When you have a lot of column in your data, along with there are many rows. Row is always a lot of rows because we deal with a very large data. But if there are columns also, number of columns also, and this kind of way, for example, filtration, sorting, group by aggregation, joining, if you are not interested in all the columns at the time of your computation, it's better to slice the required part such that you can reduce a lot of wasteful computation. So this is something which in terms of query engine, it says projection push down. So this optimization like a language like SQL does it internally when it detect the need of your final result, and it actually does this kind of slicing. But being Firedux, which comes with a compiler, it can detect the same thing and it can do the similar optimization for you, even if you have written this code, the code which we usually write. That code can be optimized to this way by using the compiler. Detected that my result will be same even if I change this kind of thing. So that is one of the example. Now let me take one of the another example which is again very frequently occur in our day-to-day analysis. That is, for example, let me now take two tables. One is an employee table, another is a country table. So employee table has a couple of information related to employee, and country table has an information related to the country. And there is some kind of foreign key, like there is kind of joining possible between this table using the country code. Now, what I want to do is I want to know the employee who are from male category and what are the counts based on different country. That is what I want to do. But since I want to do based on different country and the country name is not available in employee table, so usually what we do is like we do kind of merging two tables to get the information available in single table. So when you will do merging of employee with country table using the common column C country code. So the something this result will be populated. So you can have now a table where the employee information along with the country information available. Now, since you're interested to do this query to be performed in specific category, for example, the male category, so you will identify, okay, so this is my interest and you will just filter out that data. So this is the male data to be filtered out. And finally, your target is to count the number of employee from each country. So from each country, that means I need to group by based on my country, and then I need to perform the count on the employee name, whatever it is. So that is what the query does, and this is the pictorial implementation of this query. Again, this typical query may have a problem when you again have a lot of data in your employee table, because if you may have 50-50 ratio of a male female, or you may have a different ratio, whatever it is, but since we are actually interested in a particular category from this table, but that category extraction is done in a very later stage of your query, that is after doing the merging, which is the most expensive operation from this entire query. So if you do so, what happens is that there will be memory which will be occupied and execution time which will be taken, but that is again after the filtration anyhow is not going to be required, so it will be filtered out. So the execution time in memory which will be like consumed, because of which that cannot be undone if you write in this way. So again, like one of the simple way of solving this problem is to, since we know that that is my area of interest, again I'll be taking that particular area of interest first. So whenever possible, let's reduce the scope of the data before making it to the next step. Then it will always reduce the lot of execution time and memory requirement for your source code. So here my area of interest is to analyze based on the mail category. So I will do the filtration first. Last time we sliced the rows, slice the columns which are of my interest. Now we are slicing the rows which are of my interest. Now my interest is the mail category to be group by aggregated. So I will be doing that first. And then I will do the rest of the thing. Like I will be joining with the country table, and then I will follow it by the group by count. So by doing so, if we have a 50-50 ratio of the male and female in the entire table, I can definitely reduce my computation cost by half when I'll be doing the merging, right? So that will definitely going to help a lot of execution cost, and at the same time the memory cost when you're doing this kind of optimization manually. So the manual optimization for the above source code can be the exact, like just reorder the source code where you will be doing the filter first and then do merge instead of merge and then filter. So this kind of optimization is something which is popularly known as predicate push down. But again, if you are using a tool like Firedux, so it has a compiler, it will detect this kind of pattern, and also it will check, okay, even if I do this kind of reordering, my final result is not going to be impacted. So if this kind of call can be taken by the compiler at the compilation time, that my intention is to do this, and even if I interchange the execution order, I do some kind of reorder, my result will be impacted. So it is very safe to do so, and it will do it like as a representative for you. So this kind of optimization is again can be automated even if we don't take care at our own level. Because of course I can understand that being a data scientist or data analyst, our primary focus is to like do a lot of analysis because we have many question in mind which is solved. Like, okay, let me find this problem, this thing, let me take this insight from this data. So when we do so, we often don't think of this kind of performance related thing because that is something not that priority at our mind. But when this kind of prototype code keep on increasing and becomes ready for the production, and the real data comes in the picture, it shows performance issue. So that is where this kind of compiler related library can help you to auto optimize your source code without a single change. You yourself can also volunteer and do the same things, but that will take a lot of time. And if you think on this, maybe you can spend less time. Like, of course it's not possible to do both of these in the same time. So just do your own analysis, become being an expert in data analyst, and leave this kind of thing to a compiler engine which is FIDA specialized at. So that is like one of the very important part, like predicate push down, which is again solved by Firefox. And now third problem, which I take an example in the last slide, that since our primary aim is to improve the performance of pandas, and pandas comes with a different API, and the API comes with different parameters. Some of the parameters are very default. So since they are default parameters, we don't need to take care of specifying them during the execution. And often that can result some cost in the execution. So in machine learning, there is something called parameter tuning. Like we do kind of this kind of parameter tuning, which to improve the performance of a model or accuracy. Same thing, not same thing, but kind of similar thing is possible when you do analysis with pandas. We can do this parameter tuning to speed up our analysis. So what is that? Let me take an example to present before you. So again, this is a very simple example. So what I want to do is I want to perform the average of the salary of my employee table, and the result is to be sorted in descending order. That is what my final intention is. So just translate the query one by one, department wise. So group by on department, salary to be average, take the salary perform mean. The result is to be sorted by descending order, short values by specifying ascend equals to false. That is the typical query which will write for this particular problem. So now what will happen if we execute the query? Basically, by looking at this particular query, we may not think, okay, there is an issue, but we actually visualize what might happen behind the scene. Then maybe we can figure out, okay, this may went not good when we have a large of data. Okay, what's that? Let me take with an example, with this pictorial representation. So first, let's take an example of an employee table where I have, I guess, 5 group of department, and each department comes with some kind of salary. So now when I'm doing the group by department, so I'll be creating this five group. So I have two IT department, for example, in this dummy data, one admin department, two finance, one corporate, one sales, and I'll be just having creating these five groups. Once the group is created, I'll be aggregating the results. So the average of the IT is something like this, average of admin is this, finance is this. So this is so far this is fine. There is no problem. So I created group, I performed group by aggregation, but pandas group by comes with a default parameter, and the default parameter is short equals to true. If you check the manual of group by, it has a parameter. The parameter is short and it is default true. What does that mean? That means not only perform group by aggregation, but also sort the result using the key parameter. So here the key is department. So the result will be sorted by the department where I have this department. So admin will come first and corporate and finance and so on. So the result will be sorted. Even if you don't specify it to be sorted in just from this query, but the parameter is default, so result will be sorted. But from your requirement, you don't need the sort, but you need the result to be sorted based on the average, and that again to be sorted by the descending order. So once again, when the short value will be executed, your result will be resorted based on the salary column and descending order. So by which you can clearly identify I have performed the second last step, which is because of the default parameter in pandas, but that is again not at all required for this query. So I'll end up spending some sorting cost here. Now, there are five groups. Of course, five groups means five row, and sorting is pretty small cost because it will not take much cost. But when you have a high cardinality in your data, there are many groups, many departments, and even you have a different more than one key of the group by. So that means the multi-key sorting will be involved, multi-cardinality will be involved. So that sorting will again comes with a cost if the data is that nature. So that time it definitely give you a pain if you don't take care of this point right now. So how you can take care? Since you know that you don't need the sorting, just simply specify short equals to false because it is configurable in pandas. So we can specify the same query, but I don't need the sorting. So I can do what? I can just perform mention that I don't need the short. So please don't do short for me based on this thing. So sort equals to false. If you specify that, pandas will not perform that step. So that step will not be performed, and you can very well avoid that particular execution cost and memory which might be used for this particular short. So this is again one of the thing which is possible to be detected if I can inspect the entire query that I am performing group by aggregation, but my final result is to be sorted by some non-key, like the salary is to be sorted, not the key column department. So since this thing can be detected, the compiler can understand, okay, so but pandas default short is true. So compiler will itself impute the value short equals to false when the actual group by will be performed. So when using Firedux, even if you don't specify short equals to false, during the compilation, it will detect that I don't need the short to be done. So it will impute short equals to false, and you can actually automatically eliminate this step to be done. So that is some very specific pandas related optimization, and yet it's possible to be automated when using Firedux. So
I would like to intervene here and ask a question, if it's okay.
yeah,
Uh,
please.
you eliminated the sorting step. In this kind of table, there is no problem. However, sometimes in some tables, you have values that are the same. Let's say two countries have the same salary or average salary. In
Okay.
which case, if you run it with optimization, without optimization, you might get the same six. Let's say it was 60,000, then you will get those countries in 60,000, but you may get them switched if you sort or not sort according to their names, which
Okay.
is the default thing. So the optimization here may cause some difference
Hmm.
from the results as if it was not optimized. Am I correct?
Yes, Jacob, you're very correct in this. And once again, thank you and appreciate your query. So to answer that, there is a glitch like the short value here, the last short value which you performed. This is basically some kind of like not stable short. The default parameter is march short, so which is not stable in nature. So and but there are possible to specify the option that there is a kind parameter in short, and in that kind parameter you can specify that I want the result to be shorted and the result to be stable, the shorted result to be stable. If you actually aim for a stable short, that means the actual ordering is important for you, then we don't perform this kind of thing. So for example, short, you call short values, and let me just and here you say sorry, not here. So you say, okay, I want the result to be shorted, but I want the short to be stable also. So if this is there, so that means compiler will detect that you are interested, the order matters to you. When there is same value in the data, the order matters to you by saying kind equals to stable. So which is not default. The shorted result is not default in pandas. So it's unstable. So the order might differ based on different execution time. But if you're interested, that means the order matters to you. At that time, will not perform this step. So compiler will that it is not safe because it might change the result. So I'll not do this. But if you don't perform
Oh,
short, okay, yes,
so, okay, let me try to explain if I understood it correctly. Basically, you can tell the compiler whether you want it to be as close as possible to what pandas would do without it,
hmm,
or do its own thing without. So you're actually telling it the compiler whether you're interested in some small artifacts and some things that, or you don't care, you just want it fast. Am I correct?
yes, of course. So
Perfect.
that's completely correct, Jacob. Yeah.
Perfect. Thank you.
Okay. So, okay. So can I just go to the next slide?
Yeah. Please, please, please. I interrupted you before you went to the next one. So
It is actually very interesting query. So because when we actually implemented this implementation, that came our mind. So that is when we thought of, okay, so since it's not that safe, so having taking care of this kind of parameter is also important, and that is actually taken care. So it will, so whether the performance is important for you or whether the order is important for you, so that based on that it will take call. So it will not impact your result. So if it is not safe. Okay, so now how does Redis actually work? So basically, all this thing query, like this is the manual optimization, and it's possible. Now, how it's possible to answer that? This is the simple design of the simple architecture. So here on the very top, being a user, you will write a pandas program. So nothing new you will need to learn. So you will write whatever pandas program you may have, or you know the API, whatever. So you will write based on that. So whenever you will be writing, unlike pandas, will not be executing those instructions right after you called. Instead, we will create some specialized intermediate representation, which we call IR, intermediate representation. So that IR will be created for each respective data frame related API that is called. And then when you need the actual result to be presented before you or to be do something. For example, you want the result to be printed, you want the result to be saved in a file or something. That is the time when you actually need the result. So at that moment, the compiler will comes in the picture, and it will inspect whatever instruction is associated with that particular result, and it will try to figure out what is your primary goal is. So, and it will try to find out the pattern of optimization, which whatever is possible from those written graph of the IRs, and it will perform those optimization and create the optimized code. And finally, that optimized code will be executed by the backend C++ kernel, which is multi-threaded, and will have the multi-threaded performance. So the last core will give you multi-thread performance, but the optimized performance. Now, how? Let me take with an example. So this is the example which again I have explained in the first slide, that is push like projection push down. So where I have a data frame with the multiple columns probably, but I'm interested it to be sorted by B and result to be extracted from A. So that's the question. So when you write this code, what will happen down the line? We will create some just operator will be created, not an execution will happen. It will just create an operator. The name of the operation is something called fired as a short values. where I have some data, and on that data I just need B column to be sorted, and it will create another say variable V2, and then I need to be project from this V2, and the project target is A column only. So and the result will be V3. So these two operators will be created and nothing will be actually executed down the line because this is kind of lazy execution model. Now, for example, there is a piece of code in your application. For example, that code is print result. So that means I want this result to be printed. So after this result, maybe you write prints result. So at that moment, compiler will be triggered and it will be requested, dear compiler, please print the result for me. And then compiler will inspect whatever instruction is associated with this particular result. The result means the v3 variable here, it in its IR memory. So it will find that, okay, v3 comes with a projection, and the projection is on a v2 which comes with a short value on v1. So based on that, you can figure out, okay, V1 is a table. From that table, I want to do sorting on B and result to be computed from A. And that is when it figures, okay, I can do some kind of projection push down because I can slice the table first and do the sorting and do the whatever required. So this will create a new set of instruction when the compiler will be execute. Compiler will be like kind of IR optimization will take place. So it will slice the required column A and B first and create some temporary. And on that temporary, it will sort the B. And on that result, it will be extract the A column. So that is a clear and very simple way to understand kind of instruction code that will be generated by the compiler for this specific input instruction. Once that instruction is actually ready for you, now whatever backend you may have, if you have a pandas backend or some kind of, for example, you have created a C++ backend, even if that backend is not there, if you have a pandas backend, this instruction can be very well translated to pandas code, and the translated code will be something similar to this. Like I have the data and ab is to be sliced projected, so it will project that. Then the result, I need short value, so short value will be called with the b columns, and then on the result I need the a column to be projected, and this will be done. So these I once this IR is ready, actually you can just translate it to any library or whatever you have. If it is C++ library, you can translate this IR to a C++ API. If you have a Python library, you can translate this IR to one Python API. So right now for testing, we have tested it on pandas to see whether the pandas itself can be optimized. And then of course, by not by optimization in compiler level, we also need it to be multi-threaded and those memory problem to be solved. So we have a backend C++ kernel which is again taking care of those things. So this IR will be translated to the backend specific C++ call, and then the rest of the thing will be taking care of the backend. So that is how the compiler and backend will come, and it will optimize whatever program you will write, and it will be executed down the line with an optimized code with a multi-threaded backend kernel. So this is the pretty simple architecture what Firedex follows. So now, eh, just hold a minute. I believe I have updated the slide, but it's okay. Okay, sorry. So that slide was not supposed to be here. Sorry. Eh, Okay, so usage of Firedux. So Firedux comes with just it's an import statement that you need to know. So users get it installed using pip install Firedux. The latest version of Firedux will be there. Now you have your pandas source code. So you do import pandas spd. Instead of that, you just write import firedux.pandas spd. That is the change that you will need. But again, you may ask that, okay, I may have my program. So this is my program where I have imported module A, then module B, module C, and my own program also need pandas, so I have imported pandas. So not changing these pandas with pandas will not be sufficient if all those module also use import pandas internally. So what will happen? Do I need to modify all those files? And what if these are the module from some external library? I cannot change the source code of that library. For that, of course, what you have is we have an import hook, so which comes with -m option. So instead of just executing this program by Python program.py, you will just add -m pandas. it will do this kind of job for you. So wherever in your entire package during the execution module, import pandas is there, it will be replacing automatically the import pandas with import firedocs pandas. So that means you actually need no code modification at all. It's just a drop-in replacement of pandas. You have a pandas program, fair enough. Import, install firedocs and just use it in this way. But if you're using some kind of notebook extension, so again, Jupyter or whatever, Google Colab. So if you have a notebook, so you can simply use the extension module which you have. So you have, for example, in your Jupyter, you use import pandas as PD. On top of that, just add this line, load extension firedocs.pandas. So it will automatically change these pandas, followed by all the third-party library which might be using in your notebook. Those will be also updated to firedocs pandas and will get the speed up. So that is the only thing which you need to do. For Jupyter, add the extension. For Python script, execute it with -m option. If you want to change import statement, you can do. That is again possible. So these are simple uses. So nothing new or troublesome thing which you need to do. Now the final thing, let's talk about some benchmark. So maybe you might be aware of that there is a very popular benchmark called TPCH, which is kind of transaction data analytical framework. So comes with a lot of different data, and on the data we need to do kind of like different tables to be merged. For after merging, there is a filter operation. After filter, there is kind of sorting, group by. All those operations are in a mix in this TPCH benchmark. We have 22 different queries, and initially, the queries are actually for the SQL, which is written in SQL. But since we need to make evaluated at Pandas, so we have translated them to Pandas, and that same Pandas code has been executed with Firedocs, Modin, etc. So when comparing the performance, you can definitely see that the grayscale is for the Firedocs, and this is showing the speed up from Pandas. So you can see that Firedocs is on average 18 times faster. Sometimes it is at like almost 95 to 98 times faster also for this query, but on average it 18 times faster. Whereas some other libraries which are also the high performance alternative for pandas, for example polars and modin, etc., they are also faster of course, but Firedocs is somehow doing better when comparison comparing with them. But if we just compare with polars, so you can see that most of the queries are having almost similar performance, but there are queries where there are high performance in comparison to polars. And some of the queries, for example, right now, they are not having that beating polars, but in most of the cases, you can see that, okay, just by changing the import statement of a pandas program, I can get the speed up. But the problem with polars is that it is a, of course, faster library and like becoming very popular, but uh, you need to learn a couple of things. You need to know the syntax, you need to know its data structure, and you need to rewrite the existing application if you have something in pandas. That is something might be a challenge. So but if you love pandas API, and if you already have an like application, just use import statement of Firedocs and get the benefit. And the benefit, when it shows, it can also offer you better performance. So that is the thing. Finally, there is another benchmark. The name of the benchmark is called DB benchmark. So DB benchmark is kind of database related operation benchmark. So where the TPC, what is basically difference between TPCH and DB benchmark is that TPCH is most about like transactional data analysis, where you have a query and the query comes with a lot of combination of different operation. So where query optimization is the key, like SQL does. If we do query optimize very well, then I can get expect a performance. But DB benchmark is something where more than query, the kernel is to be evaluated. The kernel means how fast my join is, how fast my group by operation is. When I have different complexity of the data, for example, when in this benchmark there are data of various cardinality, less small cardinality to high cardinality, when data can be of one key, two keys, more many keys, and of different type, category type data, string type data, numeric data, which you regularly use in our day-to-day lives. So even if there are high cardinality, high complexity, high number of key column to be used when joining and group by, you can see when the comparison of different library available for doing same thing. For group by Firedocs, when we evaluated last month, it was on top. And for join also, it is something similar to that of DuckDB. So comes seems like third, but the execution time wise it's same. So you can think that the kernel is also that good, and at the same time the query optimization makes TPC is also better. Okay, the last, the resources. So you can check the website which is available here. So that website will give you a lot of information related to execution model and couple of tips. There is a Twitter page you may like to follow for the regular updates. Like we usually release on every Monday and Tuesday. So basically every week there is a new release, so you can get an update of the new latest information. There is a GitHub. So on that GitHub, so let me add on point, like currently Firedux is available for publicly to be used as a library, but the source code is kind of not open. So it's a closed source. So if you check on the GitHub, so you would not be able to look into the details of the source code. But if you have kind of request, feature request, like I need this feature to be supported, or I have this bugged phase, you can report that on us and we can directly interact with you. And for that also there is a Slack channel which is prepared where you can directly join us and you can get to know the information related to release and this kind of talk. And also you can get to know what is happening and directly talk with us that whatever query you may have related to performance or bugs. So, and the final, this is also very simple, like due to configuration I cannot take the name, but when we have performed some POC on a real pandas application. So some of our like user were having a large pandas application and they have migrated from just used like optimize that pandas application using Firedux. So this is something which I have heard from them, that the integration was very easy because we just install library and can use it within a few couple of minutes. And something like, since the execution time is much faster now, so they can experience much efficiency in their regular data analysis. So that is really cool motivation factor for us to do this kind of work. And I believe that if you're currently using pandas and use it, so I can express some kind of this feedback. So whatever the feedback is, even if it doesn't work well for you, please feel free to reach us and let us know what is not working well so that we can improve our library and your work at the same time. The last point, which will come to conclude the talk, that is why it is so compatible with pandas. So there are other library also. So those libraries also offer performance, but some of them are not that compatible. But what is there in Firedux which make it compatible with pandas? Being pandas so rich in API, so rich in different data types and different kind of thing. So do we actually implement all this in our library to make it compatible? So, okay, to answer that, so whenever there is a third library, there is something in this ecosystem which is called from pandas and to pandas. So each library, be it polars, modin, whatever, so they offer this kind of interface. Wherever polars is not sufficient, you can to create two pandas to make your data converted to pandas, and pandas can take care of the rest. But all the user have to do this kind of thing manually for themselves. So if they find that particular thing is not supported or not doing very good with that particular third party library, but in Firedux, that is again something which is automated. So we have the compiler. Compiler comes with some known set of instruction code. And those instruction code is again very rich. And there is hardly some percent of the API which will not cover, which we regularly use. But if there is some instruction which the compiler doesn't know right now, so of course it wouldn't be able to create the instruction for that particular API. What happens is that it will fall back to pandas in that time, and the fallback will also be automatic. Like you write your pandas code, Fidas will try to know that, do I know this API? If I know, I will create the instruction for that. If I don't know, I will fall back to pandas and I will ask pandas to do the thing for me, and I will get the result back to Fidas. So that kind of two pandas and from pandas will be automatic. So you won't get this kind of exception or error during the execution that I don't support it right now or Fidas doesn't support it right now. Being pandas, there are a lot of API which sometimes they're very rarest of API which you hardly use, but maybe you may have some usage of those. So at that time, it will fall back without any execution error. But this fallback might be performance an issue. So what you may do for that, how can you know that which part of your program is actually having a fallback and which part is actually executed by the backend of the Firedux kernel? That is possible. And based on that, you can do something. So let me explain that. So for example, you are working in some Jupyter notebook. So here in a cell, you have a panda statement. So you add the extension to make it panda fireducks. Now we have a magic command for the Jupyter, which is fireducks.profile. So if you use that, so whatever instruction is here in this particular cell, so it will be executed and it will show you a detailed of the analysis of your program. Okay. Now, for this particular case, there is a pure pandas program, but on that there is a operation called cumulative sum. Along with all other sorting group by head reset index, there is something called cumulative sum, and that cumulative sum is on the series data is something which is not currently supported, although we have planned to support in the coming releases. So, but it's not currently supported. So, what will happen is it will about your program that I don't know. No, it will not. Internally, it will do something like this. So internally, that input of the cumulative sum will be converted to to pandas, and then it will be the cumulative sum will be called on the pandas data, and the result will be again come back to fireducks using the from pandas. The same mechanism, to pandas and from pandas will be automated here at this moment with the help of the front end compiler that I don't know, and it will happen. And how you can get to know? If you use this magic command will show you what are the kernel which has been executed at backend and what are the kernel which is having a fallback. For example, most of these have been executed here at the kernel side, but cumulative sum is something which is having a fallback. Does not only that, it will also show you that what kernel is being called how many times and what is the execution time for them. So which is again one of the advantage when you use this kind of magic, because usually what happens is when you actually want to inspect the performance of a particular shield of each of the API, we usually perform the timer before and after of each API and check that okay, how much time taken by short, how much time taken by group by. But using this magic, it will actually do this thing for you. It will inspect each kernel individually with their execution time and it will show you that what is the execution time. So from this table, you can get to know that what is your performance bottleneck, and if you're having fallback, what is that particular piece of method which is not not getting executed at Fireducks and having a fallback to pandas. But here you can see that overall execution time is 42 millisecond for the sample data, out of which only 1 millisecond is having a fallback. So often the fallback happen takes place in a smaller data and not on API which is taking time. But if sometime it is having a fallback on larger data, then there are things that you may do. So, okay, this is for the Jupyter notebook by which you can get to know using this magic. But if you're actually executing some script or a program, so there is an environment variable, Fireducks flags. So if you set the environment variable with a warning flag -w fallback, so whatever API will having a fallback, it will write some kind of log that this API is having a fallback with the execution time. So based on that, you may try to figure out, do I have an alternative to re-implement that? Or if you don't have and you still want that to be used, simply just report us that I want this feature to be added because this is currently having fallback. So that we can prioritize that and we can support it our next release. So you can directly raise that feature request or whatever thing is hindering your performance. Or you may join the Slack channel, which is prepared for the public communication. So there you can communicate directly with us that this particular method I'm using and which seems to be have fallback and I'm getting a performance thing. So by which definitely we can just prioritize this kind of thing and we can associate with the implementation. As you can, if you check our web page basically, so now just let me take a few seconds to show you. So this is the web page. So where if you go to the get started, it will show you the record details that whatever version dependency is there and how you can use it. But there is a release note page. If you check the release note, we are releasing it on a every like week basis, and there are a particular section which is called removing fallback, which says that what are the method is added which was not previously supported but added to that version. And these are typically from the user responses that they want to use this raise API, so we need to add that. So if you have faced so and if you report us, definitely we'll be adding those methods here in the latest in the upcoming release also. Okay, so and here is a demo which I'll be showing just now.
before you run into the demo, there was something a few slides ago. You said that you are releasing like installation of Fireducts. You said something about not open source something, or did I misunderstand?
Okay, okay. So Firedux is publicly available as a library to be used. So it is released under BSD license. So anybody can use it, whatever purpose it may have. But
So it
source,
is open.
sorry.
BSD is an open source license. So basically, you can use it as open source.
Yeah, yeah, you
So
can. There is no problem of using that.
okay, so I misunderstood before. I thought something was not open source. Maybe I missed. It ran too fast around me. So every
Yeah,
Fireducts is an open source library. People can
yeah.
use it. Yeah, perfect. Thank you.
Okay,
You
okay.
just made it clear because I'm my bad. My bad. I
Ah,
apologize.
oh, okay. Okay, so before going to demo, that is the summary which you already have taken. This is the highlight from this presentation that there is a new library named Firedux, which is a compile accelerated library. So please, if you're using Pandas, try to use it. What you can expect not to learn anything new. The same pandas code can be used as a drop-in replacement, but you can use the multi-threaded kernel and the compiler can optimize the source code. So that is what we expect you to experience when you may try to use it on your own experiments. Now going to that Jupyter notebook. For Jupyter, okay. So I believe this link is
Please go slow here for our beginners.
okay, 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 okay. So this is something for already link is should be shared by Jacob. So basically, here is a demo where I have prepared some kind of source code starting from the installation of Firedux and what you may just need to do. So before going that, so this is a data. This test drive use a data from parking violation issued in NYC Open Data. So you can just get the data downloaded from the link, and although it is here in this notebook also. So what it tries to do is that the data is actually in Parquet format. So it load the data using the pandas method read Parquet. And after loading the data, some columns, not the entire data, some columns are loaded. So after the loading is done, it tried to perform three queries. What are the queries are like? It tried to find out the most committed, uh, most valid the US state which are mostly like violating the parking state. Just a sample case. So since we need to perform the state wise group by, so here the group by is performed on the state, and there is a method called value counts, so which will group the data and count the data and sort the result in a descending order such that you can identify the top performing states along with the violation description, and then take the head top of every group and just reshort it. So this is a simple query which it tries to do. And second is now again, which are the vehicle bodies that most frequently involved in violation. So vehicle body means I need to group by using the vehicle body to check that what is my most occurrence body in this violation, and then I need to just perform the aggregation to count the number of violation per vehicle body, and then just sort the result in descending order. So this is a second query, group by aggregation and sort. And the last query, what I try to solve is like the day of the week on which most of the violation have take place. So since day of the week is there, so I have a date column. So the day column, although this date column is kind of string in data, so since it is string in data, so if you need it to be explained more, I can definitely, but at this moment, I expect that you can understand that what is string and non-string. So the data when it's loaded is string column. So from string column, we cannot get the information on the day, year, etc. So the data is converted to the date time column using the as type method. And once it is date time, so we can just convert like, okay, we can get the weekday, and on top of weekday, we can get for example, 0 means Monday, 1 means Tuesday, and we can map this kind of dictionary on the weekday to get the actual name of the weekday. And then on name of the weekday, we can perform a group. Okay, how many violation have taken place on Monday, how many take place on Tuesday, and so on, by using the aggregation count and sorting the result. And finally, there is an evaluation result. Okay, which query does what much time when executing in pandas and when executing in Firefox. So now, just since it is a Google Colab, so it comes with only two cores. Since there is only two core available, so multi-threading performance might not be experienced that much. And this query is also written carefully, so there is not enough room for compile optimization. But just for your sake, if you have some local machine which is prepared with this kind of thing, so you can just get it downloaded and execute. But okay, let me first execute on Jupyter from Google also, and my own local system also. So now simply just in order to download it, it's open. So you can just get it, download it using the pip install. So it will try to create a connection and the data will be downloaded. The library will be downloaded. So it will take some time to download the library, not some time, and it's also very lightweight. So it will just be not occupying much of your memory also. So once the library is downloaded, I believe it is still downloading.
Yeah.
Okay, now the library is downloaded. So what you can do is, okay, before executing using Firefox, now maybe it's better to check what if without Firefox. So since I don't want to use Firefox right now, so this is my typical pandas import. Just execute the pandas import and see that whether it is actually pandas or file or what anything else. So PD is the instance of pandas, and name and version you can check that what is the pandas and what is the files which is used here. So you can see that pandas version 2.0.3 is used. Okay, safe to go. So now you can just get the data for this evaluation. So it will be downloaded in a couple of seconds. So the data is downloaded, so you can just get the data, and once the data is downloaded you can just execute the query without any problem.
How big is
So
the data file?
sorry.
How big is the data? How many records? Like a million?
Okay, a million, I believe so. So the data is, there are this many of rows in this data, just one pocket data, but you
15
can
million. 15 million. 15 and a half million. Okay.
so now execute this query. Now it is being executed using pandas. So pandas try to load the data. Sorry. So here is something I have added for the evaluate,
You missed a step.
which is
You,
not
you changed the step.
sorry. This is not required for pandas. So let me just comment it and why I need it. So I'll explain, but let me just not evaluate the result. Simple pandas code, so execute it. So it is executed and data is before you. So there are 15.5 million and 5 columns. And the second query is being executed, and where I am getting trying to get the maximum number of violation by the vehicle, not vehicle body, by the US states. Third is by vehicle body. I will be executing that. And the last one is the day on which most of the violation takes place. So executing that. So once the executions are done, so you can see that, okay, so when I use pandas, this is the situation. So overall it's around 14.7 seconds and 3 seconds in data loading and 4.15 seconds are for each query. So pretty simple. And I am using Google Colab. So it has, I believe, two core. So by using the nproc command, you can inspect, okay, there are only two CPU cores which is available. So now let me do the same thing. Now this time I will be using Firefox. So now since I'll be using Firefox, I just need to install the library. But since I have already installed the library, I don't need to reinstall it. I will just enable the extension module. That is the only thing which I need to do. So when I will it, do this and execute this again, so this time my PD is changed from pandas to Firefox automatically. and the latest version of Firedux will be using, right? And now let's do the same thing. Data is already downloaded, so let's not execute this line now. Since I already have downloaded the data, it is there in this current session. Now, okay, so why I needed that evaluate for Firedux? Just to show you that my execution has happened. Okay, now last time I said that whenever you will ask to do something, for example, read parquet, it will not actually be reading. An instruction will be created that I need this data file to be loaded whenever it is requested. But since it will not be actually executed, so even if I measure that time, it will not be giving you the actual timing for the loading result, right? So that is not good. So how can I explicitly invoke for benchmarking purpose only? But for your real application, you don't need it. But since I'm benchmarking here to show you that the speed, so what I want that div instruction, whatever instruction is associated with that result is to be evaluated right here, such that I can measure the execution time. And in order to do that, we have a method called underscore evaluate. So if you perform that method, so that means whatever instruction is associated with this div, that will be executed. So that is why when I'm using Firedux, I need to enable this. But with pandas also, if we just since there is a check that is the evaluate is an attribute is available, then do it. So even if we execute it with pandas, it will be just as a no operation, it will be skipped, but you can get to execute the same query. And your real application, you don't need to do that, because in your real application, wherever there is a data is needed for saving, for aggregation, that time it will be actually evaluated, because you don't need to check the performance of each cell. Now you need to check. So that is why you may need this kind of explicit evaluate to instruct the compiler then to execute this right now. So when I will do so, the the library is executed. The Firedux will now be loading the data, and the data loading exactly take place and see that data is loaded before you, whatever the time that will be resulting later. So again, here I have a couple of query that project some column, do value count, then group, then head, then short, then
You
reset.
they evaluate. You have to they evaluate back.
Yes. So R1 is the final result, which is currently just some set of operation, nothing else. So I need to evaluate just because I want to measure the execution time. Not if you don't need to measure, you can skip it. So when I do so, so it will be executed, and similar way for the second query, and similar way for the last query, third. So all these operations have been executed and they are evaluated using Firetux. So now the final, so what are the execution time this time? So that is the last time with pandas, but now this time you can expect almost half of the execution time, because you have two core available. So you can expect 2 times faster. So if you have a multi-core system available, so multi-threading performance will actually be visible to you just from this demo. Now I have something for the same thing. I have my own system with 8 to 24 codes. So when I execute the same code, like import Firedux, do this stuff, and the same thing. So when I executed last time, so uh, just because it will be quick, so let me show you. Ito. For Firedux, ito. First, let me show it with the pandas, because even if there are many core, pandas will not be able to speed up. So pandas will take that much of time only, whatever it will take for on a single code. So it will execute all those things, and the execution time is around 8 to 9 seconds. When I checked last time, okay. So okay, now it is something around 6.5 seconds. So these are the time for each of this query. And now so overall 6.4. Now I will just execute it with Firedux and re-execute all the kernels, and you will see that since I have many core available, so the performance will also be like 0.4 seconds. So from 6.5, 0.4 second execution speed up you can achieve just by installing the library and adding this extension, nothing else. So yeah. And now if we actually don't want this, if you feel this evaluate is something which is bothering you, that we had to put the evaluate which result to be evaluated, for that also if you don't want to do that, so let's forget that evaluate is there. So if you want to make it eager model like in pandas, so like whenever you will call an API and the API should be executed, that is also possible. So how you can just check the eager execution mode of Fireducks without explicit evaluate, just enable the environment variable which we called benchmark mode. So there is a environment variable benchmark mode. If we enable that benchmark mode, what will happen is the lazy execution mode of Fireducks will be stopped and it will be executing everything as in Panda. So once they are called, they will be executed. So you can just simply benchmark each of the API without any problem. So now since it's already installed, so I just let you show restart session and run all. Yes. So
If you're
it is
starting the
now
set,
being executed.
if you're
Uh,
starting the session, it will forget it. You need to load it. Uh, well, it's
Jacob, did we lose him on mobile?
no, no, no. Wait a second. Yeah, there might be something wrong here. He had some issues. Maybe his phone died. Uh, Saurabh, you got disconnected. Let's wait for him a minute. He might reconnect. Here, I say we can't hear you. Maybe. Thank you for noticing. Hopefully, he sees those things pop up on screen, but he might not even be able to see it. Uh, yeah, we lost him again. I am. Uh, I think we just lost the communication from his phone. This is how he was speaking. He used a different machine to actually. I think maybe his just battery died. Maybe he'll plug it in and it will work. I have no idea. Um, we'll wait a minute for him to join. Uh, he's explaining something. We'll have to come back to it. But first of all, we'll have to wait for him to reconnect. Uh, okay, we'll wait for him for a minute. Everyone, in the meantime, you can ask for you can think about questions you want to ask because it was extensive and what he's showing is elaborate. I know that there's some beginners here. They may be shy about the asking questions. We might want to wait with those questions for a minute. Uh, Okay, some Evelyn is here. Okay, have you had the chance to compare fire duct flexibility in performance versus DuckDB? Evelyn, he actually showed a slide for that. You might want to catch the video later, but once he returns, you'll ask him and he will do this. Apparently, it's comparative to fire duct, approximately. Sorry, to DuckDB. So but let him answer it properly. They did do a comparison. He just needs to join somehow. I think it just his phone died because he was speaking from his phone. Maybe the battery is dead there. This is my assumption. I have no idea what happened, but let's wait for this to be fixed. But it's good to see you, Evelyn. Let's wait a few more minutes for everything to come back. He will be joining. He solved this problem before, so we'll have to get back to the point in the presentation where he was, and then we'll continue. I'm not going to edit this out when I put it on YouTube because it's not worth it. And well, we keep it as authentic as possible. We don't want to censor anything unless really necessary. Yeah, we'll wait a few more minutes. Derek, thank you for joining us. You're welcome to join in the future. I apologize, but technical issues always seem to have, especially if we're doing something long distance like this from all the way from Japan. We actually have multiple countries in our audience tonight. So no, it's not only US and Japan. So I'm from Israel, so let's wait a bit more. Okay. We're still waiting for the speaker to rejoin with the audio. In the meantime, I can tell you that we had several dealing with pandas, something very basic that many people in Python do. So I was excited to see one more library that deals with it. We dealt with multiple libraries that deal with, I won't say insufficiencies of pandas, but pandas did a lot. It was a groundbreaking library when time it came out, but everything gets old in time. So the fact that there are new libraries that do things better, I would say, or at least differently, then this is really, really good. This means that the ecosystem of Python is getting better and better and better. So I'm happy to see it.
Jacob, it's good to see you as well. Maybe while we're waiting, you can tell me more about the comparison.
We are being recorded now, so let's wait until after the recording. We'll go back. We'll go back to this and we'll go to the free format soon. But while we're being recorded, let's keep on the demo. Oh, here's Saurav.
Hello.
So Evelyn, you can ask him your question the minute he arrives. Saurav, can you hear us?
Yes, Jacob, I'm really sorry. One second, I
No,
connected.
that's okay. That's okay. We'll keep it authentic. When you put it on YouTube, you'll see what we were talking while you were not around. We're basically waiting for you. Can you go back to the point in presentation where you were showing? It was at the end of the demo, and then you were talking about other things. You were trying to tell us things, and we couldn't hear you. So go back to the point where we lost you.
Okay. So what he actually was saying in the demo that okay, so this is not, that was which the link is shared in Google Colab. So the exact same thing which I have in my local system, which has
your local system we've seen you run it once, and then you run it another time, and then it was many times faster, and then you run it by removing the flags, and this is where we were cut off approximately. So
Yeah,
we
yeah.
go ahead.
Okay. So basically, that is what I wanted to say. That since Google Colabs come with only two scores, so you may not seem that multi-thread performance. But if you have even if CPU system, but with having multi-core, so it will be giving you much fast performance. So it's up to you. Like yeah, whatever system you may have, you can experience based on that. So because it is multi-thread, at the same time, the compile optimization is also possible for you. So that was what basically I was sharing from this local version and the collab version. Yeah, and then I guess I conclude that this is what I have. So if you have any questions, please feel free to ask me. Like and that is when I guess I got disconnected. And I already have something in the chat I can see. If you like to say me that if I miss something
Evelyn,
and some.
Evelyn is actually online. You see him in the video. Evelyn, ask your question.
Mhm. Yeah, please. What?
Yeah, thanks, Ralph. I did join a little late. There was another meetup that I had to attend and ended up late. But I saw your slides towards the end comparing to a few other libraries. Um, I've been playing with DuckDB for a few months and I'm pretty impressed. Have you had a chance to compare those two?
Sorry. So you mean to say that you have been using DuckDB, and the question is?
Yeah, in terms of flexibility and performance. Okay, I
Yeah.
see that 1, 2, and 3. Got it. Okay, very cool.
Okay. So
Appreciate it.
basically, to answer your question, that uh, our primary focus. So when we thought of creating the library, primary focus was to like optimize the pandas because it is something which is mostly used in the data science community, and it is something which is having a many third-party library written on it. But DuckDB is something which, as you might be knowing, that it comes with the SQL-like of interface. So you simply write some kind of SQL query and it can execute it on behalf of you in some local in-memory database. So if you prefer to write something on SQL, definitely DuckDB is a choice for you. But if you're somebody from the Pandas backend and want to still experience the same kind of thing, the same kind of query optimization and multi-threaded thing, so I believe Firedux is something which you can think of. But as far as the performance is being compared, so like this is one of this like DB benchmark. So there are different queries in DB benchmark, and which comes with different data complexity, as I said some time ago. So where also when I compared the DuckDB performance and Firedux performance, it seems like there is like sometimes it is faster in case of Firedux and sometimes it is very close to DuckDB. So in a nutshell, that of course not a bigger application which is written in DuckDB, because whenever I need to do something in DuckDB, I need to rewrite the application. But whatever is available, and when I checked the Pandas and DuckDB version, the Firedux using Pandas was much faster. And but of course, we don't support the SQL kind of interface because it is written for the Pandas. So API was there is difference, but flexibility and because it is possible to do this kind of query optimization and choosing of the parameter can also be handled. So performance wise, more or less, you can say they are same. But there might be chances that DuckDB can perform well because DuckDB is simply performing translation of SQL to this kind of DuckDB native space. So there is lot of optimization which is possible, which is not currently a problem with Pandas, because Pandas comes with index, Pandas comes with different complex parameters. So there is often a hidden cost. Whatever optimization we try to do using the compiler, but some hidden cost we need to pay because of the original way of writing in Pandas. So that may impact sometime, but gradually we're updating many patterns and so to just mitigate that gap. So and target is also the Pandas community, because there are many third-party library at plotly and something is developed. So to optimize them, so
Yeah.
having something compatible good. So that is what we try. Yes. So
Yeah, all
does this answer
clear.
your
Thanks
query?
a lot. So the
Ah,
drop-in replacement is the main benefit, and it's also the restriction on how far you can optimize without breaking compatibility.
yes.
Understood. Appreciate it.
Thank you.
More
Once.
questions, please.
Yeah. So
Yeah,
Joseph,
Joseph,
sir.
you don't need to raise your hand, Joseph. You can just ask question. If you cannot write it in the chat, then I'll read it. You can.
Hello?
Yeah, Joseph,
Hello. Mhm.
we can hear you.
Oh, hello. Yeah, I was just want to say like I'm kind of just glad to be here, and I was just wondering like you were mentioning like Firedox is Firedox kind of like a upgrade, like kind of like a upgrade for pandas, correct?
Yes, you can think so. So although it's a different library, but it's kind of optimized on top of pandas. Yeah.
Okay. Um, wouldn't is that kind of like design it like for Firedox and pandas? Is that kind of design mainly? Is it mainly designed just only for databases, or does it have some flexibility to it too?
For flexibility too.
Uh,
Can you
like
do can you do anything other than databases, like database stuff?
Of course,
correct,
of
yeah.
Of course. So database is, as you know, that pandas also doesn't do with the database, right? So database something is a different thing, a different altogether is a different concept. But pandas is mostly for the data manipulation and data analysis. So, for example, if even if you have a CSV data, if you have a Parquet data, whatever data you may have in the text format, in a raw format, the data has to be loaded. Basically, the primary objective of pandas is for the machine learning training data kind of creation, right? So if you check, if you're from a machine learning or AI background, so what happens is that we collect the data from different sources, from different sensor, camera, whatever sources it have, and then we find them to clean them, uh, create a lot of features using group by join, etc. And then we create some kind of structured data for our AI model to understand. So this is where the pandas is mostly used, and Firedux is also belonging to that platform. So it's not only for the data, although it can target for that also, but mostly it's for the data analysis and manipulation. Whatever is possible with pandas, everything is possible. So you don't need to think that something is new here. The only new thing is that you need to pip install this library, and maybe you need to change the import. Apart from that, if you are from the pandas background, whatever is possible with pandas, the exact same thing is possible with Firedux and that level. So you can think of it's a pure data analysis and manipulation tool, not something which is very core to database. So if you don't have database, it's fine enough, because we really don't deal with the database on a day-to-day when we do kind of AI and ML related thing.
Oh, okay. Thank you.
Yeah, my pleasure.
I, I have a question. It relates to other libraries we've seen in the past. It's not the first time we see a library that kind of mocks the pandas this way or another, or tries to do things to it a little bit better. We had actually in this meetup we had several of those. One that I didn't see on your list that actually I'm not sure it does exactly the same thing, because they do it a little bit differently, but they do have elements of closest, is one's called Bodo. Um, a few years ago, they presented with us, and they have basically a JIT thing. You just Bodo JIT or something like, or some JIT compiler that you put on top of your function. So do you do something similar just behind the scenes, so you don't even have to write the JIT?
I don't know what the Bodo actually does. That is a little new for me. Thank you, Jacob, once again for the question. But ideally, like there are other this kind of JIT, like for example, Namba or this kind of libraries also there. So
Yeah. It's a decorate. It's a
Mhm.
decorator that they add. It's something very similar to Namba, but has to do with data, and they also accelerate things.
Yeah,
But they gave us the presentation a few years ago, and now I see that they're working something with snowflakes. I don't know exactly what's happening there. Like I know that they had like a pandas acceleration thing, but
Okay, okay.
I don't know. Now it's something seems to be different. I'm not
Yeah.
sure. Maybe I'm wrong. Uh,
Oh,
but
thank you, Jacob. Of course, the mentioning is really appreciating, so I will definitely check. But so far, whatever from our research and thing is that, so of course, as you said, that since pandas is something which is having a problem and it's very well known, so there is different library which has been developed. But the mostly the problem which I faced and encountered in my initial work that some of the library doesn't offer full compatibility with pandas. So often it happens that we need to do this kind of thing like manual source code changes by doing to pandas from pandas kind of thing due to the execution errors and all. And some of the library also require some specialized hardware, for example GPU. Like if you have, for example, if you talk about the CUDA, so you can get the performance if you increase from CPU to GPU. So of course, paying some hardware cost or paying some kind of migration cost, rewriting the application is something which can make you increase the performance of your application. But from the pandas backend, having that exact compatibility and without even upgrading your own execution system, you can get performance benefit. That I believe something which is currently possible with Firedux. And all of the library, their library, for example, Modin can also do to some extent, but the performance is Modin is not up to that level right now. And for the Bodo, I need to check how much it comes, even if it does IR related thing, but it might comes with some its own API. So again, our native pandas application, how much it's compatible, how much it can be executed, I'm not really sure. So maybe I can check. But these two challenges are new, are known, that I may need to change source code, so I may need to pay migration cost, or I may need to upgrade the execution system. So that two challenges is something which you may not encounter with Firetech. So that is kind of a unique thing.
okay, I just wanted like check out they're called Bodo.ai, and I have no idea what they're doing today, but a few years ago they gave us a very nice presentation, so this is
Oh,
why I mentioned them. Maybe there's something there that could be even useful for everyone, who knows. um One last question, unless someone wants to jump in. Anyone wants to jump in with a question, or can I ask one last one?
I've got some questions if possible.
Go ahead, Jeff.
Okay. The first question is, in your presentation, if you weren't using Jupyter and you were just using it in a straight IDE, is that what it is? You just import Pandas PD and then you list firedux.pandas. Is that how you would enable it?
yes, that's
Okay.
correct.
Okay.
So
The second question is, you've listed in your presentation multi-threading, in the sense that, I mean, I think of it as multi-threads on one process, but it appears it's the like multi-processing. And I'm just wondering, I mean, are we talking about
okay.
like pure multi-processing in the sense that it's like not sharing the memory and that it's got its own, each process has its own interpreter?
Okay, okay. Thank you for the question, Jeff. So the first thing is that, so it is actually multi-threading. It's not multi-processing. So every threads can share the memory. So that is one of the thing by which we avoid a lot of serialization of the data. So because whenever it is multi-processing, there is a extra cost that we need to pay. So during the transfer of the data among the each nodes or among the each process which is there. So the threads can share the memory. The threads can share the memory.
We're losing you,
They
Sarah.
can exchange the information, but
Wait.
like without any problem. So it's sorry, Jacob, can you hear me?
Yeah, can you repeat the entire last sentence, because it's like you
What I
got
see.
disconnected.
We can hear you, but you're delayed.
Okay, sorry. So what I said is that it is not multi-processing, it is multi-threading. So the threads can share the memory. We can reduce the copy cost and serialization cost for that, and do the parallelization also in the thread level, which is being taken care of right now.
Okay. One other question is, I didn't see, do you have to specify the amount of cores to be utilized, or how does that work?
Okay, so of course, so currently if you don't specify it, so it will be using all the available cores in your system. But since it's a multi-thread system, so once again, thank you for the query, Jeff. So it's really important and something I missed in this presentation. So that is how can I configure the number of core to be used? So for that, simply like variable environment variable OMP num threads. So you can specify OMP num threads to the number of cores you want to use. For example, if I say 4, and then instance fire duct, so 4 core will be used. So how many number of by default all cores, but if you can configure it using the environment variable OMP num threads.
Okay, great. Sounds good.
Is there a
Thank
way
you.
to actually do it is there a way to do it programmatically, like within Python, not always dot set environment, but like, is there something within Fire Duct that says no, I want to use only 4 cores, like some sort of system call or API that's
Okay, no, no, nothing as such. So, for example, right now, most of the methods at the kernel side, they are parallelized based on the available cores. Like for example, of course, there will be for if you have, for example, if you're reading multiple files and there are not many files, so some of the cores which will not be used, but by default, all the cores will try to be allocated and
yeah.
they will be tasked, and the balancing load balancing is also taken care of. But if you have really small data to work with, then of course some of those threads will not be used. So
Uh,
the automate
I'm asking something different. Can I do this not from the operating system? Meaning, like here, I'm using Windows. I don't want to write the set command or whatever. Yes, I can do it with Python and write the set environment command, but I want to do it with Windows, and I want to I want to do it through the FileDuck interface. Is there like FileDuck.options and then specify
ah,
number of cores equals this? Is there some system call for that?
understood. So again, so system call is not there, but since Firedux is a panda, so of course you can import OS, and the environment variables can be set here, right? So for
Okay.
example, so here you can adjust the number of core you want to use. For example, OMP num threads, and say for example 2 or something. You can do this
Okay.
way, Pythonic
Okay.
way.
This is current. It would have been nice to have this internal, but it's good enough for now. As
Yeah.
long as it's
Thank
compatible within systems, it's
I will
good.
take I will take a note on this. Yeah.
Uh, um, anyone has anything else before? Should I ask one more question?
Yes, Jacob, please.
Okay, so you said it's good for AI. AI actually does need specifically a lot of tricks to actually prepare data, and a lot of the AI libraries now work directly with pandas. There are those that even have extension, like Evelyn a few years ago operated like here. TensorFlow had the TensorFlow. What was it then, Evelyn? The one that IO, TensorFlow IO. So Evelyn brought it and was talking about. He actually contributed code to this a while ago, a few years ago. So you have all sorts of like AI libraries directly working on top of pandas. The way you described it, they basically should work natively because you can always fall to the pandas command. But if you're
Mhm.
using TensorFlow or PyTorch or some other library that interfaces, does it
Mhm.
like, do you have on your end, do you have many requests from people who use the AI libraries on top of pandas to actually for features that will improve things? And how compatible are you, or anything you can relate to this?
Okay, fine. Thank you once again, Jacob. So again, so for AI, if I segregate the domain, so there is something the core machine learning, and there is again something called deep learning, right? So deep learning will talk about not only text data, so there it will come like video data, audio data, this kind of thing will also be there. So when we'll do like this kind of recognition. So and TensorFlow and PyTorch will come in the picture when we'll be mostly doing the deep learning kind of thing. and there is not enough scope for pandas when we do deal kind of thing. So
Oh,
definitely
they,
for
they do. They do. Sarah, those do interface with pandas. They allow also things that pandas does.
they
You
do.
can
I
directly feed them data from pandas.
sorry,
Almost
Jacob, can
directly. I would say almost.
so you mean to say that PyTorch and TensorFlow
TensorFlow. Yeah,
hmm, can interact with pandas for some of their part?
yeah. So if I replace this now with FireDAX, according
Mhm.
to you, it will be almost smooth and accelerate things. Do you
Yeah,
have
yeah.
any like evidence or stuff from people who work with it? This is what I was asking.
Okay, so to be honest, like third party testing, like those library which is currently internally using Firedux, for example, you said one of these one is TensorFlow, but usually what happens is that the visualization library like Matplotlib, Seaborn, missing number, Y data profiling, these are the library which is most featured tools. These are the library which are mostly used pandas internally for creating features and doing a lot of cleaning by automatically. So those using the extension of load xt fighters to pandas, internal pandas processing can be accelerated. And we have started doing this kind of demo and recently actually, so to see that how compatible fighters with the third party libraries which is currently most popular among the community. So as of evidence, I cannot share something for the benchmark which I have presented. Maybe down the line when I have some record ready, I'll be able to show you. But from the executing point of view, when I tried this library which I named Matplotlib, Seaborn, Y data profiling, and features tools kind of thing, so they actually executed integrated pretty well with Firedux, and their native pandas computation was accelerated using Firedux. And some of them are having issue with the performance because we often see some fallback take place, so which definitely is a plan that those fallback can be supported to execute it in our kernel instead of pandas. But as for the execution point of view, that can be executed. And regarding the evidence, once again, maybe I'll be able to present that something up maybe in coming session if you allow me to do so. Right now I just have experimented and tried that it works well. So if you have, so definitely you may like try and let us know.
Perfect. You might want to talk with the Holoviz and Plotly people because they also build like they have those interactive plots that are like HV plot and all of those. Then there's like those are the ones that actually use the like HV plot is actually built on top of pandas in a sense because you actually take a pandas data set and then just call a plot on it. But you might want to talk to those guys, but this is just an idea and we can talk about it offline. If it's okay with everyone, I'm going to start the recording now. Anyone has anything about the recording? Wants to put in on record anything? If not, then let us all thank Saurabh. Please make some noise, make some images here.
Thank you so
So,
much.
yeah.
So I believe someone, okay,
Yeah,
Joseph,
Joseph,
Mr. Joseph.
you wanna clap or you wanna raise your hand? You wanna ask a question?
Figuring out the buttons.
Echoes. Yeah, Evelyn, ask your question. No need, just jump in, unmute yourself, but just don't do it together. That's the only thing.
Thanks, Raf. Great presentation. Appreciate it.
Thank you, Evelyn.
Great,
So glad,
great meeting by the way.
my pleasure, Joseph.
Okay, everyone seems to be happy. So in that case, if everyone's happy, what I'm gonna do is I'm gonna stop the recording. Don't go away. We are still continuing this meeting, but I'm just stopping the formal part that's being recorded. Again, thank you, Sarav. I'm stopping now.